Here we are in West Virginia. Isn't it beautiful? All right, so are you ready for joke of the day? And I've got a joke that is just great here for the gorgeous scenery of West Virginia. So why did the scarecrow get an award? Because he was outstanding in his field. All right, let's not stand around. Let's take a look at perfect square trinomials. So we need to recall when we get into this idea of a perfect square trinomial, let's start with this. Now this x plus 3, that binomial is being squared. We have a binomial squared here. Now remember, when you have a binomial squared, that doesn't mean distribute the power, even though we love that song. What squaring actually means is it times itself. So remember, what this means is this x plus 3 times itself, x plus 3. And now that you see that, you know you're going to FOIL it. And x times x is x squared. X times 3 on the outside is 3x. 3 times x on the inside is another 3x. And then 3 times 3 on the back is 9. And we know we're going to combine up these like terms to be a 6x plus 9. This is what we call a perfect square trinomial for a couple of reasons. One being that it's a trinomial. It has 3 terms. Perfect square is for 2 reasons. One being that this first term right here is a squared term. The square root of x squared is just simply x. This back term is also a squared term. The square root of 9 is a 3. In addition, this is a perfect square trinomial because it factors into a binomial squared. Notice that if I go backwards into factoring this factors as an x plus 3 times an x plus 3. Back sign here tells me same signs, both pluses, so plus and plus. Split this into the front slots as x and x. Split this into the back slots, and like I said before, 9 times out of 10, if it splits evenly, that's how it's going to go. So 3 and 3. Here's where we need to be careful. Whenever you see something times itself, keep those eyes open. When you see something times itself, write it as quantity squared. It times itself means it squared. So in other words, this is a perfect square trinomial for a couple of reasons. I've got perfect square here in the first term, perfect square here in the back term, but it factors into a binomial squared. And notice there's a pattern that I can use. That pattern is this. Once I've identified the square root of that first term, it'll go in the front slot. Once I've identified the square root of the back term, it goes in the back slot. I will simply remember that this means same signs. This will tell me what they are. So that sign will go right here, and I'll write it as quantity squared. So that is the pattern for perfect square trinomials. To recognize a perfect square trinomial, though, you need to recognize that you will have a squared term in the beginning, a squared term in the back with a plus sign. Notice here, this is double the product of these two. So if I take this and this factor and this factor, multiply them together and double it, I get my middle term. That's exactly what I see here. Square root of this is a, square root of this is b. If I multiply those two and double it, that creates a perfect square trinomial. Same thing here. Square root of this is a, square root of this is b, multiply them together and double it, that gets the middle. So if I want to use a pattern, then what I'm going to do is I'm going to say square root here, square root here, this sign goes between them, and I'm going to square the whole thing. Similarly on this one, square root here, square root here, take this sign and put it in the middle, square the whole thing. But as I've said before, I don't know about you, but me, I'm not that great at memorization anymore. I used to be amazing, but not anymore. So I am not going to utilize the pattern. Me, I'm going to go through the process of factoring that I've been doing all along. And that process says, this back sign tells me they're the same, this tells me both pluses, plus, plus. I'm going to split this into the front slots, I'm going to split this into the back slots, check my outsides and insides. Out here I get a 3x, in here I get a 3x, like I see right there. Those combine to be the 6x. This is the correct way to factor it, and I'm going to keep my eyes open. And whenever I see quantity times itself, I'm going to write it as quantity squared. that will get it right every time as long as you keep those eyes open. So let's go with that idea and take a look at this example. Always, 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 always look first to see if there's something common you can divide out before you do anything else. There's nothing common here, so I'm going to head for that double parentheses, and I'm not going to utilize that pattern. I'm going to go with the factoring methods that I've been using all along. This tells me same signs, this tells me both pluses. So now what I'm going to do is split this into the front slots as an X and an X. I'm going to split this into the back slots. I want two numbers that are going to multiply for 25 and add for 10. Sure enough, that's a 5 and a 5. I'm going to check my outsides and insides just to be careful. Out here I get a 5x. In here I get a 5x. Sure enough, those combine to be that 10x. That is the correct way to factor it. And I'm just going to keep those eyes open. I see quantity times itself. So I'm going to write it as quantity squared. And that's the correct way to factor it. Because I know that this indicates x plus 5 times x plus 5. And when I FOIL this, I get back to the beginning. Because remember, I should always be able to get back to the beginning. So let's take a look at another example. You know I like for us to see several so that we get very good at this and nothing surprises us. Once again in this example, always, 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 always look first to see if there's something common you can divide out before you do anything else, and there is not. So I'm going to head for that double parentheses because I don't know about you, I'm not that great with memorization, I don't have the pattern memorized. But I do know that this tells me same sign, this tells me both negatives. So I'm going to split this into the front slots, and I'm going to have two numbers that will multiply for 49 and add for 14 because these signs are the same. That's a 7 and a 7. I'm just going to check my outsides and insides to be sure. Out here I get a negative 7x. In here I get a negative 7x. Those combine to be a negative 14x, which is exactly what I wanted. I know that's factored correctly, but I've got those eyes open. I see parentheses times itself. Whenever I see parentheses times itself, I'm going to write it as parentheses squared. And that's the correct way to factor it. Because again, I can get back to the beginning because I know this means it times itself. And then when I FOIL this, I get back to the beginning. All right, let's try another one. So always first look and see if there's something common you can divide out before you do anything else. Nothing common here, so I'm headed for that double parentheses. Same signs, both pluses. I'm going to split this up into the front slots. Most definitely the x squared splits up as an x and an x. Now that 4 could split up as a 4 and a 1 or a 2 and a 2, but I'm going to try that 2 and 2 first. I want two numbers that are going to multiply for 25. That'll be a 5 and a 5. And I'm just going to check my outsides and insides. Out here I get a 10x. In here I get another 10x. Those combine to be the 20x, so I know that this is factored correctly because I know that 2x times 2x is 4x squared. I know 5 times 5 is 25. It's factored correctly, but I've got those eyes open because I see parentheses times itself. That indicates to me parentheses squared. And I know that this feels like a tedious step. Why on earth is it so important to write it as quantity squared? This is important whenever you are working with quadratics. And whenever you work with quadratics, in order to be able to, say for instance, complete the square in the quadratic, to be able to find the x-intercept, this is a very important skill. So just get into the habit right now that every time you see quantity times itself, write it as quantity squared. And so now the last one, anything common that you can divide out? Well, it feels like it because I can certainly divide both of these by 2, but this is only divisible by 5. Now that's divisible by 5, but that's not. I can divide A's out of both of these, but not this one. I can divide B's out of both of these, but not that one. So there's nothing common that I can divide out. So I'm going to head for that double parentheses. And once again, same signs, both minus. And I'm going to split this into the front slots. Definitely an A and an A. Definitely here is going to be a B and a B. Now that 64, it could be a 64 and a 1. It could be a 32 and a 2. It could be all kinds of stuff, 16 and a 4. But it does split as an 8 and 8. So if it splits evenly, I'm going to try that first. And the same thing here with the 25. It could be a 25 and a 1, but it could be a 5 and a 5. I'm going to try that. So now out here, I know 8a times 8a is 64a squared. I know negative 5b times negative 5b is a 25b squared. Out here, I get a negative 40 AB. In here, I get a negative 40 AB. And that does give me my negative 80 AB that I wanted. So I know that this is factored correctly, but those eyes are open. And I see quantity times itself, so I'm going to write it as quantity squared. Such an important step. Get into that habit because it is insanely important to do that. So hopefully what you're seeing out of perfect square trinomials is whenever you can split that front term up evenly, whenever you can split that back term up evenly, then you can write it as a quantity times itself. Just keep those eyes open and write it as quantity squared. Very important step. I hope that helps. Have a great day.